Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I would like to show you the continuation of my big throttle project. As you can see in the previous video, I've already shown you how I've done the features of the bottom casing, which is we have 4 keys there. Right, and also we have a cutout from the second snap hook from the opening lid, and also I've shown you how I have done since we have the keys, so we have the cutting here, the groove for the keys, and also part of the cutout from the second hook, snap hook from the opening lid. And also from the opening lid, I already shown you how I did this second hook for this opening lid. Alright, so this video will be the continuation. Okay, this video is about how I will do the detailing of this bottom casing. Since the bottom casing, we have some features here. We have kind of like a rib supporter to hold the 2 batteries, and also I will show how I will do supporter to hold the DC motor, and also the supporter to hold we have a metal connector from the motor, metal connector to connect the batteries. Right, so alright, in SolidWorks, sometimes when we do part modeling, sometimes we can go to assembly mode where we can do detailing of our part. Okay, let me show you. Because since when we do part modeling, we always use, when we do part modeling, we go for part modeling mode. But in this case, since I want to do rib supporter for this bottom casing to hold the batteries, I will go to assembly mode where I will position the 2 AAA batteries, which I have done modeling on it, and also the DC motors. I've done the part modeling on DC motors, so I will put the location in assembly mode. Then from there, I know the position where I will put the rib to support both the 2 AAA batteries and also the motor. Okay, let me show you how I will do this in assembly mode. Alright, to do this, okay, in assembly mode, so I will go in assembly mode here. Since this is our part modeling, where I have this is typical part modeling I've done before. In this part modeling, I have 3 components here where I have bottom casing, top casing, and the opening lid at the back. But actually, just to need to mention to you, because later I will delete all the other part. For example, I will make it as a separate part file. For bottom casing file, I will delete top casing and also opening lid. Then I will save it as bottom casing. And for the top casing, also I will delete bottom casing and opening lid and save it as top casing. And the opening lid, I will delete both bottom casing and top casing and save it as a opening lid. Because later, I think the last part of this video, I will show assembly. But at this moment, for a while, I just remain it this main file where we have 3 components: top casing, bottom casing, and opening lid, and I open it in assembly mode. Okay, in assembly mode here under the new file, I click at the arrow here. So we have make assembly from part assembly. So SolidWorks will directly open the assembly mode. So this is the interface of the assembly mode in SolidWorks. Alright, in this video, I will not show you introduction briefing what is assembly just for a while, because the purpose of this video is for me to show you how I do detailing of the bottom casing in assembly mode. Okay, if you look here, the interface here, we have begin assembly where we can insert the parts that we want to put in our assembly. Since I already have the main casing type B here, my main file just now from my part modeling is listed here. I simply click OK here, the green button. So it will put our parts here into assembly mode. Alright, so if you look at the first component that I put, I just simply click OK. It have the listed here is bracket F. F means is fixed mode, so it cannot be moved. Right? Okay, my idea here, I want to do detailing of the bottom casing. Alright, so what I will do is, since we have the feature manager, the list here, it's kind of similar like part modeling. I click that the cursor here. under the solid bodies here, I want to off this one, I hide it, and also the top casing also I will hide it for a while. I just want to remain, it shows only the bottom casing. All right, the idea of this, doing this in detailing of this bottom casing in assembly is because I need to insert two AAA batteries where I know the position of that two AAA batteries. So from there, I can trace the outline where I will do the rib supporter to hold the two batteries. Okay, to do that, okay, under the assembly here, we have insert component. So I will browse where my AAA batteries. Hold on, I've already done the modeling on these AAA batteries. Okay, I have this one. Okay, this is my AAA batteries here. I put it somewhere around here. Okay, now I will position these AAA batteries into a right position. Alright, to do that, I will do a mate setting. Here, under the assembly here, under all the menu, under assembly tab here, we have mate. For the mate here, I can, okay, the idea of mate is that we put our component into the right position in our assembly. So we have the setting on the left here. Under the mate setting here, I will do the setting to position my AAA batteries into right position. Alright, if you look here, the listing on the screen here, okay, let me close this one. This is our assembly, is the main file. Okay, if you look under, I open the cursor here, we have, okay, the main casing is our bottom casing all together with top and on and the opening lid. What I mean is this AA batteries. I click at the cursor here, I want my, can you see the highlight the front plane of these AAA batteries? I want it to be aligned or to this. If you see, if I select the front plane, it's already listed in this mate selection. I want this front plane of this AAA battery to be aligned to the front plane of this bottom casing. So I will, my second setting here, I will go for front plane. Okay, for bottom casing is not front, because front plane of the bottom casing is like this. I mean on the right plane of the bottom casing. Since why? Because the front plane, the right plane of the bottom casing is in the middle. So I put it in that position. I put that in that position, and I want it the distance to be, since the battery AAA battery diameter is 5 millimeter. So I will put the position here is 5 millimeter. Okay, 5 millimeter related to that right plane of the bottom casing. I remain it like that, then I click OK. So if I click OK, now my position of my, if you look from the top view, as you can see, this is the middle line. So we have 5 millimeter from the right plane of the, I can drag my AAA battery, but it's remain on that location, 5 millimeter from the front plane of the bottom casing. Right. Okay, another thing is about the level of these AAA batteries, the level, because if I go for this view, I can still move it up and down, but I want to put to the exact position of this level. Okay, to do that, I will do another again of the mate setting here. Under the mate here, okay, I will go again. Hold on. The AA batteries, the top plane of that AA batteries will be aligned with this flat plane of this bottom casing. So it maintains on that level. It will be put on that level. So then I click OK. My mate setting is now in that level position. So we already done the two mate setting. One is about the position of uh, between the front casing of the, between the front plane of the AAA battery and the right plane on the bottom casing is 5 millimeter, and the level is up until this surface. Alright, another thing is about the to location of this under this Z direction. What location do I want to put it? Okay, to do that, okay, I will on again my under main casing here. I have since I off the opening lid at the back, I show it. Alright, now my second setting is that I want to do distance from this face to this face is 5 millimeter. So to do that, I will do again mid setting the surface here up until here. So by default, it will go for coincident, it will touch that plane, but I want the distance to be 5 millimeter. That will be the position of my battery. Then I click OK. Then I click OK. Okay, this is my setting of my first battery. All right. Okay, since I have two batteries, I have another battery to be put here. So I will do the same procedure. All right, to do that, instead of me insert triple A batteries again by insert browse where I save my triple A battery. Instead of doing that, since I have the original battery here, I can clone it by hold down my control key and I select this battery and simply drag it. And now I have the clone version of these AAA batteries. Now I will do the same procedure. I do the mate setting to put the second battery into the right location. All right, under the mate here. So what I will do here. All right, this is the bottom is the battery number two. Okay, here I will go for that front plane will be aligned with the main casing right plane. Hold on, main casing right plane. So I will put the distance is 5 millimeter. Then I click OK. So I have the first setting. So in okay, the location in terms of front plane and the right plane of the bottom casing is 5 millimeter. And another setting is that let me off this thing for a while. And for the second battery top plane and the surface is aligned. So that's will be my second setting. All right, my third setting is that since I want the second battery to on into different direction, not the same direction as the first battery. So my third setting is this surface and this surface. Okay, I put it, the distance is 5 millimeter. Okay, 5 millimeter, I go for flip dimension. Then I will go here under mid alignment, I go for anti-line. So it will go to that location. So then I click OK. So now I just click OK here. Then I click OK. Then now my battery are in position. Alright, my next move is that I will do detailing of these bottom casings because the purpose of this video is for me to show you how I will do detailing for this bottom casing. But I begin this detailing of this bottom casing in assembly mode. Since my two AAA batteries are in the exact position that I want it to be, so then I will do, in this assembly, I will do a supporting rib. Okay, this assembly mode. In assembly mode here, when I select this bottom casing here, we have a menu appear here. I will go for the edit part, the second icon here. When I click at the edit part, if you look in the list at this feature manager here, we have our main casing are in blue color. It's in blue color. It means that we are editing this main casing, but not the, because another component that we have in this assembly is these two AAA batteries. These two AAA batteries are not in blue color. The blue color is for this bottom casing. This main casing file that I have here, where I have bottom casing, is in blue color. Blue color means I'm now editing this bottom casing. All right, if you look at the icon here, it's I'm editing this bottom casing. All right, I want to make a supporting rib for these two AAA batteries. So what I will do typically, if you look, the setting is kind of similar like in part modeling. Under the features, I have a reference geometry where I can create a plane. So what I will do, I will create a plane start from here. Then I put a distance about, this is the location where I want to put my first rib to support these batteries. I will put a location about maybe about 14. This is the position I want it to be, 14, where this is my location to make my first rib. So I create the plane here. So this plane here, alright, since this is the plane already created, plane number 14, so I will right click at it and I go for sketch. So I'm now in sketch mode of this plane 14. Remember, I'm editing this bottom casing part file, but in assembly mode. Okay, here I'm in sketch mode. So what I will do, I will select the contour of these two batteries. So I will go for convert to entities. I just simply click OK. I just simply click OK. Then I have the trace of that outline of that two AAA batteries. Okay, now I exiting the sketch mode, and also I exit the edit mode. So what I will do, I will go back to part modeling mode because now I'm in assembly mode. I simply select this bottom facing here, then I go for open part in position. So now I'm back in part modeling mode, like uh, like what I have done before for part modeling. So now I'm not in assembly mode. I'm part modeling mode. As you can see here, we have the already plane 14, and we have already the trace outline of our batteries. All right, now I can edit this cache. Okay, edit this cache. So I go to normal view. So what I will do is that since if you look, the trace outline of these two AAA batteries are still in blue colors because stated down here is underdefined. I got to make it fully defined. So I just put a dimension, for example, like this to here is 5. Because a good practice, you don't leave your sketch in underdefined. I have to make it fully defined. Put the dimension is 5. I do not change any dimension. I just putting adding dimension to make all these sketches is fully defined. The diameter is 10 here, and also diameter here is 10. And also we still have blue color because in terms of the positioning of this here, this dot and this origin point must be horizontal, and also this origin point and this center of this circle is must be horizontal. So now I have a full define. All right, the another thing is that I need to make a line here because I want to make a rip up line. So I need to put a line here. I will do set midpoint line. Sorry, I will do just a typical line here. I put one line here. Make sure it is horizontal. As long the line is longer than that two circle. So the distance from this line to the let me put dimension from this line to the origin is I put it about 2 millimeter. 2 millimeter. So I put a dimension of 2 millimeter from this point to this line, right? Okay, this line I don't have to make it fully defined. As long as this line is extended longer than these two circles, it's okay for me to create the rib. Alright, the distance is 2 millimeter from this origin point. Alright, then I will do trimming. I will do trim. So I carefully select part which one that I want to remove. So I have this outline. So this outline is good enough for me to create the rib. Alright, so here under the features here, I have a rib. Okay, the thickness I want it to be 1 millimeter. So thickness is here is 1, and also make sure that the pointing of the projection of the rib is toward downward. And make sure the selected bodies here, I select this bottom casing. Then I click OK, then we have a rib there. Right? So we have a nice rib. So this rib would be the supporting structures to hold the batteries. Okay, but since I need to make another 3 more ribs, another 2 more here. If you look here in the assembly mode, it is automatically updated. So we have the supporting rib here that hold the two batteries. Alright, I go back to the modeling mode here. Okay, let me save my file first. Alright, then other two ribs here, I cannot make, since we have a linear pattern, I cannot do linear pattern since, remember that at the beginning when I do this part modeling of this bottom casing and top casing by doing lofting, it's kind of like not a straight edges. So I need to make the same thing again here, since this is part modeling. So what I will do here, I will create another plane. This plane, I will add at a distance of 12. Will be my second supporting rib. Okay, second plane here for me to create the same procedure that I've done for the first rib. So here at plane 15 here, I will create a sketch. But for the outline here, okay, let me exit my sketch first. If you look under the feature manager here, the first script that I have made by default, SolidWorks off it, so I make the sketch shown, so I have the outline there. Alright, okay, for this plane 15, so I make a sketch on this second plane here, so I will, what I mean is I convert to entities. It will trace all the outline that I've made uh, on the first script. So I check all that curve, then convert to entity, so I have this on my current plane. Okay, similar approach, I will do rib and make sure the thickness is 1 and directing of arrow is downward, and I select this body, so I have the second rib. Right, then another one, I make another plane here by distance of 12 or so this direction. So this plane, I do edit sketch, and I trace this outline. And convert to entities, then I will do the third ribs. Okay, make sure pointing is downward, thickness is 1, selected bodies this one. Then I have the third rib. Let me save my file. Okay, if you look here in the automatically in the assembly mode, so we have all the three supporting ribs that will hold the battery for this bottom casing, right? So this will be my supporting ribs for my for the batteries. All right, the next thing is that if you look onto this assembly, let me off these two batteries for a while. Okay, when we try to, let's say there is a complete product together enclosed with the top casing, when we try to fit in the two AAA batteries, there might occur that the batteries cannot really slide onto these three ribs because due to misalignment. So it means that I have to add another features here, a kind like a cross member here. It means like I will do a kind like a rib here alongside, and one is this side, another one is on the other batteries. We have kind of a horizontal rib. So the idea of this horizontal cross member rib here, this cross rib here is kind like it will guide the batteries into when we try to fit in the batteries. So we can like to avoid misalignment, so the battery can easily slide onto these ribs. Right? Okay, to do that, in the if I go back to the part modeling mode of this bottom casing here of this main casing, so I need to put a cross rib, a horizontal rib along here. So to do that, I need to put create a line here, create a straight line here. But before I create a straight line, I need to put where my plane position. So I can do that by sketch 3D here. Sketch, if I go for 3D sketch, I only need to put location of point. My point will be the middle point of this curve. So that will be, so this is my point in 3D sketch. Okay, the idea for me creating this point is for me to put location of my top plane to be starting on that point. So under the features, so I will put a plane here, plane, and my first reference will be my top plane, and the second reference will be this point. So I have a plane there. So that plane 19 here will be on that point. So I will create a sketch on this plane. But before I create line, let me go to perpendicular view. I draw a line here. Make sure we start at here and stop at, make sure it is horizontal and stop at here. So the idea of this line is for me to create a rib, right? To create a cross rib. So here under the features, I have a rib. So make sure that if you look, the pointing of the rib, pointing of the material is to the left and to the right. It's not right. So I have to click here, make sure it's pointing downward. And the selected body will be this body, then we have a cross rib. But if you look at the rib, I think it's too, let me check, I think the rib is too thick. If I edit the rib, is actually must be 1 millimeter. 1 millimeter is enough for me to create the cross rib, right? So I have this cross rib. Okay, about the here, this one, I don't have to do it again since I believe my right plane is really in the middle. My right plane here of this, my right plane of this main casing is in the middle, so I will do mirror. So right plane is already selected, and features to mirror is this rib, so it will be projected onto the next one. All right. So we have we have two ribs here. The idea of this rib is we can easily slide the two triple batteries onto these three ribs without misalignment. All right. So we have features. All right. The next thing to do is that I've done creating these two cross ribs here. Okay, this is part modeling mode. Then when I go to assembly mode, so it is automatically updated. So we have the two cross ribs here. All right, let me on back my two batteries here. All right, this is in assembly mode. Okay, the same like what I've done for these two triple battery, I will insert another component which is the DC motor. Okay, actually I have already done part modeling of that DC motor, which I want to put in exact position here. But before I do part modeling of that DC motor, I have already done research from the internet, from Alibaba. I have already found out the suitable motor for my milk frother, for this milk frother in terms of size. The capacity of the motor is 3 volt. Since we have two batteries, each is 1.5 volt, and the motor have 10,000 RPM, and also in terms of high torque value. So that motor is good enough, suitable for this milk frother. So the motor, actually, this is the image of the motor that I found from the Alibaba, but I cannot put the exact location of the Alibaba, so this is snapshot. So in that site in Alibaba, they already give the exact dimension of the motor. Then I've already done the part modeling exact dimension of this motor, right? So here, in the assembly here, I will insert the motor. Okay, I will insert the motor, right? The DC motor. Okay, this is the motor that I've done. Okay, the exact size, the motor given from the internet. Okay, now I need to put the exact position of the motor for me to create the supporter on the this motor casing to support the motor. All right. Okay. The first thing is that I need to do mate setting to put the motor in exact location. But if you look carefully, the motor shaft here and if you look here, the output here, I have kind of like a curve here. It need to be concentric. It means that the shaft and the circle that I've created earlier by loft here, it need to be have a relation to share the same center point. It means concentric relation. So I need to on back the curve that I've made here from the beginning when I do modeling of this main casing here. So if I go back to the part modeling mode, so this is my part modeling file on my main casing. If I bring up here at the beginning where I do loft here, so I have this sketch tool. This sketch tool by default SolidWorks will off it when I've done lofting, so I need to show it. So the curve is showing here. So if I go back to the assembly mode, so the curve will be shown, right? So the curve is here. So I can do relation of this curve and this cylindrical surface of this output shaft or the motor have the relation sharing the same center point, which is concentric relation. So I will do mate. Okay, I will do mate. So I will select the shaft of the motor and this circle. Automatically SolidWorks will put it into concentric as shown here, setting on the left here. So I click OK. So I have the relation of the concentric. So it means the motor shaft and this circle share the same center point. Alright, but I can still drag the motor, but the motor you can see I can still rotate it like this, but the axis is remain the same, concentric, right? Okay, another relation about this one. Okay, since if you look at the surface here is horizontal, right? So this face and this face automatically SolidWorks will set it to parallel, so it means it remain horizontal. All right. Okay. Another thing is about the distance here. The distance from this face to the face of this battery, I already measured. The exact location is about 5.25. Okay, 5.25 location. Then I click OK. Then I click OK. Right. Okay. Now the if you look here, in the feature manager of this assembly file, under the mate setting here, if you look, the list of this, all the listing of the mate setting that we already done. If you look the last one, the DC motor here, I already put it 5.25 distance. So it means the position is 5.25. Okay, now the motor is in exact position. Alright, so now it's about time for me to create the supporter to hold the motor. Okay, the supporter that I will create is kind of like similar what I've done for these three ribs to hold the battery, but the location of the supporter is around here. So to support, we have supporter on here and also supporter on this cylinder. So we have two positions to put kind of like a rib that we will be put onto this bottom casing. Right. Okay, to do that, okay, so similar like what I've done for to create the rib to support the batteries. So this is under assembly mode. So I will select this bottom casing here, then I will go for the second, the fourth icon here, edit part. So if you look here under this main casing, uh, become blue color. So it means that I'm editing this main casing file. Alright, so since I want to create a supporting rib to hold, first is at the back position of this motor. This motor here, we have a big cylinder here. Since I have a flat surface here, I don't have to go feature manager to create plane. Since I have a flat surface here, so I select this surface, then I can do sketch here. I simply click OK. Now I just trace the outline of the motor, the edges here, then I go for convert to entities. I simply click OK again. Then I have the outline of that back features of this DC motor. So let me do this first. Okay, the next one will be, okay, I exit the sketch. I exit the sketch. Okay, the next one will be, okay, I'm still editing this main casing file. The next supporters will be on here. So I create, since we have a flat plane here, I create a sketch, click OK, then I just select trace here, the edge of this cylinder here. Then I go to convert to entities. Just simply click OK. So I have the trace outline. Then I exit the sketch. Then I exit the edit part mode. Then now I open part in position. So I go back to part modeling mode, right? So in my part modeling file here, I have the trace outline of the two batteries. One is at the back, this circle, and this circle is on the front. So I edit this one, the back one, I edit the sketch. Okay, if you look here, the sketch still like not into, let me go to this view, normal view. It's not fully defined, so better to make it fully defined rather than leave it just blue like this. I put it 5 millimeter. Just remain it like that because I don't want to change the dimension because this is what the trace outline of the motor. So I put another position from here to here just to give dimension as long this curve is fully defined. So this will be another dimension. So here will be the other dimension to this point. Just leave it like that. Now the circle become fully defined black color. All right. Okay, the next thing to do, okay, here I need to create okay, if you look here, I need to create a rim. I have to create a line. Okay, let me go for midpoint line, also can do from starting from here. Then I just, as long it is horizontal and it is longer than the circle. Okay, this one I don't have to make it fully defined. So I remain it like that. Now I do trim. I just remove the parts that I don't want that. I just need to have the outline for me to create the rib. So this is good enough. Okay, I don't have to make this fully defined. Okay, I have the outline to create the rib. So now under the features here, rib. So make sure the thickness is 1 and about the pointing direction. If you look here, it's pointing upward. So I go flip material side, pointing downward. Selected body will be decreasing. Then, so we have the rib. Alright, if you look here, the rib kind of like we have it producing a solid wall. If I go back to assembly mode, so we have automatically it will be updated. Then if we look here, we have a solid wall. It's kind of like intersect with, because the motor here, we have the metal connector at the end here. So I don't want it to be intersect with this. So I mean, I need to make a cutout. So it means the rib will, the only supporters will be about this length. So the rest of it will be a cutout, right? So to do that, So I go back to the modeling mode. All right, here, since if you look here, I have a flat plane here. So I create a sketch here. Okay, here I can trace the outline here. If you look, we have edges, this one. Since I want to make extruded cut, I select this edge and also this edge and also this edge. Under the sketch, I convert to entity, so I have a trace there. So I simply draw a line here and it snapped to that point. Then I give a, okay, I think the distance here, I already measured the exact distance here to be 1.75. All right, 1.75. Okay, 1.75. So then I will do extruded cut. Okay, hold on. Okay, 1.75. So under the features here, I will go extruded cut, but now I'm using selected contours. So I just need this region to be extruded cut, but I'm not using blind. I'm using up to surface, then I click the surface, then I click OK. So we have this thing, right? So we have a cutout. Let me go back to assembly file just to check. If you look here, all right, if you look at, we have a cutout, and now the wall here, the supporting structure is not intersect with this metal connector of this motor. All right. All right, I will do the same on the other side since I cannot do mirror, since if I do mirror for this, because I need to do the same thing again. Okay, here I make a sketch here. I make a sketch here, so I will trace this, convert to entity. So I have the outline there. Create line, then I create line here. Make sure it's vertical and it's snapped to that point. And the distance from here is 1.75. Right? Right. Then I will do features, extruded cut. Then I'm using contours, this one. Then up to surface, this surface. So I have these features, right? Okay, I have these features. Okay, about this thing, something it happened like this. Okay, we kind of like have a extra cutout here. It's okay if I go under surface here and I select this surface. Okay, if carefully select this surface, then under the surface here, I have delete face, but I'm not deleting. I go for second option, delete and patch. So automatically it will solve the problem. So this thing is still remain solid. Just to check, this casing is still solid. It's not hollow. We have internal volume, right? Okay, just to check. So we have no kind of like excessive there. So I have the features here. Let me save my file first. All right. Okay, for the front one here, similar approach to what I've done for this at the back of the supporter for the DC motor. So at the front here, I will edit the sketch. Right, then I go to this view. Right, it's still not fully defined, so I need to make it fully defined by giving dimension. Okay, now it's fully defined. Okay, then I will do midpoint line. From here, make sure it's horizontal and it's longer than the circle. Then I will trim this part to get the outline. Then I will do rib. Material is pointing downward and thickness is 1. And select body is this part. So I have a solid wall for the rib. So I don't want to make it as a solid wall. I want to make it as the same similar like at the back here for the DC motor. So I kind of have a cutout. All right, here I have a plane. So this one I create a sketch on here. Then I will go for convert to entities. Then I will create line somewhere here and make sure it's vertical and it is snap here. Beside giving dimension 1.75, I also can make a relation. This one and the edge collinear. All right. Here also I don't have to. Okay, I do this first because I cannot do mirror on the other side because we have two separate surface here. Okay, I do this first and I do this first. Then I go for features. Through the cut. Then I'm using contours up to surface. Select the surface. Then I have this for the front supporter of the DC motor. Right. Just need to remind you again, I cannot do mirror because when we do mirror, we extrude cut up to surface. Since this surface is left surface, it's not a continuous surface. So I have to do it again here. So I create a sketch here. Then convert to entities. Create line. Make sure vertical and snap here. This one and this one. Collinear. Up to surface. Alright, let me save my file again. Then I have these features. This is two supporting features here by doing ribs, and I also have make it cut out to hold the motor. If I go back to the assembly, so we have the okay. But if you look here, one thing that I forgot. Okay, here the both here. If you look at both of this rib to support the motor, it's kind of like intersect. Okay, these two rib I have to do edit these two ribs because the location of the rib I make it at the middle. So I go back to this modeling mode of these two ribs here. Okay, under here the rib of the first rib here, sorry, this rib, I edit the first rib. Since I'm doing the middle option, in the middle, I have to make this one in here. The first option is going to the right. So the rib, this one is going to the, it's not in middle, both in, the rib is not constructed based on the middle axis. So it means it's going to the right. For this rib, right, for this rib, I edit this one supposed to be the first option to the left. Okay, it go to the left. Then I click OK, so the rib is now in exact position. If I go for, I check in the assembly file. So now, okay, now the rib is not have a intersect with the motor. So it go to this direction. This one it go to the left direction. Okay, let me save everything here. Okay, now I have already shown you how I created the two supporting structures or ribs to hold the DC motor. Alright. Okay, another thing is that we still have the same problem that before here. We have excessive cutout here. Alright, so this assembly mode. I open the part modeling mode. So under here, hold on. Under here, under the surface tab, right? I select this face. Then under delete face, so make sure the second option delete and patch. Then I click OK. So we no longer have that excessive cutout. So this one is still solid. Okay, still solid. We have blue color there. Alright, let me save my file. Alright, my next move is that let me go back to the assembly file. Alright, the last thing to show you in this video for me of this detailing of this bottom casing is I need to put in here between the DC motor and the batteries we have a metal connector. Okay, the metal connector I shown in this image. I already done research in internet here, from Shopee. Here we have a spring connector to connect the batteries and also connect to the DC motor. So this spring connector. So this is a bigger image. Right. So we have two kinds. So on the right, on this right corner here, at the up right corner here, this one, I already done part modeling on this based on the exact size. And we have a spring and we have kind of protruding to touch. One here is to touch the head of the batteries. The spring to touch the flat surface of the batteries on the other orientation. So I have already done the part modeling on this spring connector with the exact size given from the spec of this product, right? So here in the assembly, so I will insert the parts. The name is um, battery connector. So I will put it somewhere around here. Okay. All right. Now this uh, spring connector here. Okay. If you look here, we have the on the other side we have a spring, coil spring. The other head we have a protruding head like this. Okay, that protruding head will be touching this battery on this orientation, this head, and but the spring will be touching on the battery this orientation on the flat surface of this battery at the back here. So this means that this surface will touch this surface, right? So I have to do mate setting. And so we have the relation of this cylindrical surface of this cone must have the concentric relation with this cylinder. So I have to do the mate setting here. So under the mate setting here, I will go for the cylindrical surface of that cone must mesh with this. So we have, I click OK, we have the concentric relation. All right. Uh, okay, before I do that, let me undo this thing first. Okay, if I go for, okay, this cylindrical surface of this cone and this one concentric, but okay, you have the relation concentric. Under here, the main alignment, I go for the left one here, anti-align, so it will go to that direction. Then I click OK, so I have the mate setting of the first one. Okay, they have a relation of concentric. It maintain the same axis, but I can still slide it out like this, right? Okay, another thing is about this surface must touch this surface. So it will touch coincident, right? And have this okay relation, but I still can swing it. Okay, the last setting is that this space and this space must be go for parallel relation. So I already kind of fixed position for this spring connector. As you can see, as okay, it's touch here, the batteries and the spring touching the other end of this battery, right? Okay, now I will do similar that I've done for the rib to support the triple battery and also supporter for this DC motor. So I will do the same. I will do the same approach. All right. Okay. My next move is that since I am in assembly mode and I have already put this spring connector, this metal connector in exact position. So what I will do, I will okay edit this in this bottom casing. I select this bottom casing. I go for edit part. So on the left here it becomes blue color. So I'm editing this bottom casing in assembly mode. So what I need to do, I need to trace the outline of this metal plate here. But the outline I want it to be is on this plane. It's not on this top plane or this plane. Before we have this protruding lips of this bottom casing. So since I have a flat plane here, so I can create a sketch here. All right, so I go for the perpendicular view. So I will trace the outline of this metal plate. Then I go for convert to entities. So I have the outline. Then I will exit. I will exit edit part. Then I will go for part modeling mode. Okay, now I'm part modeling. So I have the trace outline there. Alright, I don't want to edit this trace outline here. I create another sketch plane here. On this same plane here, I create another new sketch plane. Then I go for perpendicular normal view. So what I will do, I will create a line, start from here, goes like this, and extend up until Yes, up until here. I can go here, right? And I create another line from here like this. Make sure that I touch here. This is good. Okay, this one I can select this edge here. I can go for convert to entity. So I have a trace outline there. Okay, about that I need to join this line since I have a create another line just to join it, right? So I have a closed shape there. Okay, about the dimension here, this is 0.5. Okay, this one also 0.5. Okay. Okay, the idea of me to create this, I can use box extrude to make a kind of a slot. Okay, this I will do features, extruded boss base. I'm using contours here. I select this region. Sometimes by default, SolidWorks it check on the thin feature. I uncheck the thin features. I only need the contours that I want for me to boss extrude to this direction, not upward. So I go for downward and it go for up to surface. So I go to the surface, then it will stop at the surface. So we have these features, right? These features. All right, the next thing to do. All right, if I go for assembly mode, okay, I have already this thing. All right. Okay, I need to make a cutout since we have metal plate will be put into this slot. I have to make a cutout to create a slot. But I need to know the distance from here to this edge so I can measure it, evaluate. I can measure from this line to this line, the distance if you look here on the y direction, since y is upward 4.5 millimeter. So what it means that in my part modeling, I will make a cutout. Okay, I will go for this sketch, right? So then I go for normal view. So I will create this. I can simply trace the outline here. And this one and this one, I can just convert to entities. And I can boss extruded cut. Okay, be careful about this thing. Sometimes the thin feature is always checked. Make sure it's unchecked. Then I'm using contours. I'm using these contours, and the distance is 4.5 for me to cut out. All right, so I have a slot here. Okay, let me click OK. Hold on. So I have a cutout here. Okay, and okay, if you look in the assembly, so it nicely automatically updated. Then we have a slot for this metal plate, metal connector to be slot into this cutting, this slot, right? So I have to do the same on the other side here. All right, about the other side here, I cannot do mirror since remember when I do this for extrude of this, it toward the surface of this surface, but this on the left right side is a different surface. I cannot do mirror features, so I will repeat the same procedure as what I've done for this. All right, so here I go back to part modeling mode. Okay, I will create another sketch plane at this plane. Normal view. Okay, for this, I will create a line here at this point. Extend like this. I extend it. I can even extend to this direction here. As long as snap here. And another line here. These edges. And also this one, I can convert to entities. Alright, so I have to join this line to make it a closed shape. And I give a dimension 0.5. And this one also, hold on, 0.5. Alright, so I will do features, box extrude. I'm using contours. I select this region and make sure thin features is unchecked and direction is downward and up to surface. So I have this. Okay, so this flat plane here, I create a sketch. Then I will trace this outline. Hold on. I will trace this outline. Over to entities, features, extrude cut. Okay, uncheck the thin features. Then I go for select contours. These contours distance is 4.5. So I have a nice cutout here. That's what I've done on the left. It's kind of same goes for the right. Okay. So this will be the slot for me to slot in the spring connector. So let me save my file. Okay, if I go to the assembly mode, okay, now I have the features that I need for the bottom casing. Okay, I believe this is the only things that I can for the bottom casing, all the features. Okay, I've completed the features needed for the bottom casing, where we have the ribs to support the batteries, the slot to support the metal connector, and the two ribs here to support the DC metal. Alright, inshallah in the next video I will show you how I will do detailing for the top casing and also of the this opening grid at the back. Alright, thanks for watching this video. But before that, please do subscribe my channel and click like. Assalamualaikum warahmatullahi wabarakatuh.